This paper, titled, LLMs Meet Finance: Fine-Tuning Foundation Models for the Open FinLLM Leaderboard, explores how large language models can be adapted for financial tasks. The researchers from the University of Maryland fine-tuned two foundation models, Qwen2.5 and Deepseek-R1, using specialized techniques to improve their performance on a benchmark called the Open FinLLM Leaderboard. The Open FinLLM Leaderboard is an open platform designed to evaluate how well large language models handle various financial challenges. It's based on a dataset called FinBin, or Pixio, which includes 36 datasets covering 24 different financial tasks. These tasks span 7 key areas: information extraction, textual analysis, question answering, text generation, risk management, forecasting, and decision-making. For instance, information extraction might involve pulling key data from financial reports, while forecasting could mean predicting market trends. In their work, the team employed several advanced techniques to enhance the model's capabilities. They started with supervised fine-tuning, or SFT, which is a process where the model is trained on specific datasets to align it better with financial contexts. For SFT, they used 28 out of 41 available datasets that provided training and validation data. The loss function for this is defined as the negative log likelihood of the model predicting the correct answer given an input query, which mathematically looks like this. LSFT equals negative log of pi theta of y plus given x, where theta represents the model's parameters, x is the input query, and y plus is the correct answer. Beyond SFT, they incorporated direct preference optimization, or DPO, and reinforcement learning, or RL. DPO helps the model learn from preferences, essentially ranking better responses over worse ones to refine its outputs. Reinforcement learning adds another layer by allowing the model to learn through trial and error, rewarding actions that lead to better performance on financial tasks. They also used chain-of-thought prompting, which encourages the model to reason step by step, much like how a human might break down a complex problem. The researchers built on existing work in the field. For example, they referenced datasets like FNSPID, which provides a massive collection of stock price records and financial news articles from 1999 to 2023, covering thousands of companies. Another key reference is FinLLM Meta, a library that turns real-world market data into environments for reinforcement learning, similar to gym-style setups in AI training. They also drew from studies on LLM-enhanced agents, such as FinLL Deepseek, which combines reinforcement learning with large language models for trading. Additionally, they mentioned the Financial Regulations Challenge at Qwen2.5, where teams like FinMindYme used techniques like sequential fine-tuning and task-specific prompts to achieve top results. Other related efforts include using LLMs in multi-agent systems to simulate micro-level behaviors in financial markets, helping to model real-world dynamics without assuming perfectly rational agents. The main contributions of this paper are noteworthy. First, the team fine-tuned Qwen2.5 and Deepseek-R1 models using SFT and DPO, resulting in substantial performance improvements across a wide range of financial tasks on the Open FinLLM Leaderboard. They observed that these enhancements made the models more effective at handling diverse challenges, from extracting information to making decisions. Second, they leveraged reinforcement learning and chain-of-thought prompting to generate and synthesize new data. This approach not only improved the model's financial capabilities but also demonstrated how these methods can be used to create more robust training datasets. Third, the researchers measured the data scaling law in the financial domain. Scaling laws describe how a model's performance improves with more data or parameters, and they found that in finance, these laws align closely with what's been reported in general NLP literature. This means that as you increase the amount of financial data used for training, the model's accuracy and effectiveness grow predictably, which is valuable for future developments. Throughout their experiments, the fine-tuned models showed significant gains, highlighting the potential of large language models in real-world financial applications. For example, in tasks like question answering or risk management, the models became better at providing accurate, contextually relevant responses. By integrating these techniques, the paper underscores how foundation models can be adapted to specialized domains like finance, paving the way for innovations in areas such as intelligent decision-making and personalized financial services. The use of open-source models and benchmarks like the Open FinLLM Leaderboard ensures that these advancements are accessible and reproducible for the broader research community.